What's going on, everybody? This is Mr. Diamond, and wow, the lighting on this is so much better than the other class I was recording. Look at this cool blue color instead of that harsh, bright white color. You may notice that I'm streaming from the Diamond Cave as opposed to the classroom. This is our new house, and I'm trying to get some videos in before this homecoming weekend. Since I'm pretty busy, going to be pretty busy this weekend. This is going to be. We did an intro for Chapter 2. This is technically the first lecture for Chapter 2 of Organic Chemistry. So Section 1, Chapter 2. We already talked. Get my cool pointer going. We already talked, or I mentioned already in the other video, that there are functional groups in chemistry, and that you basically will want to have these things memorized. I'm going to go into these in more detail. Man, oh, that cool blue color went away. That's sad. I'm going to go into these in more detail, and we'll have a section after this one where I'll talk about each one and give it the time it deserves. But like I said, just getting the shape down and the name down, it takes a lot of time, so I wanted to tell you about that as soon as possible. Now, what we're going to talk about now, blue color's back. Cool. Okay. Alkanes is the first thing that we're going to talk about. Formulas that contain mostly hydrogen and carbons are called, creatively enough, hydrocarbons, because sometimes scientists are sometimes they do want to make your job easy. Not all the times, not most of the times, but in this case, they were like, well, it's made out of a bunch of hydrogens and carbons. What if we call it hydrocarbons? Don't think it involves water. That's a big mistake people make. Depending on the types of bonds connecting them together, we can give them slightly more specific names. So alkanes involve only single bonds between the carbons. I'm gonna get ASMR real quick. The between the carbons. It is very, very important that you're only caring about the stuff that is between the carbons. You can have a carbon double bonded to an oxygen. That's cool. You can have a carbon triple bonded to a nitrogen. That's cool. It's still an alkane. We only care about the bonds between the carbons. And alkanes are single bonds only. But as soon as there is one double bond, it immediately becomes an alkene. So if it involves at least one double bond between carbons and no triple bonds, it becomes an alkene. So notice that A has changed to an E. So an alkene is a hydrocarbon chain that has at least one double bond between the carbons and no triple bonds between the carbons. I'm going to have to make that more clear in this actual note slide. And then if, God forbid, there is in fact a triple bond between carbons, you have then moved to the alkyne. So notice that we went from A to E to Y. So alkynes, if there is at least one triple bond, it does not have to be any double bonds. Doesn't matter if there's 40 billion carbons. If there is only one triple bond, that thing is suddenly an alkyne instead of an alkane. So these are the three major categories of them. We can do some identification real quick. So looking at these, go ahead and try to figure out which of these are. This is actually me telling you. Sorry. Oh man, the blue color went away again. It sucks. So notice that these are all alkanes, even though this thing is gigantinormous and it is huge. There is no double bonds here. In this one, it's also an alkane. There's only single bonds. This one has a double bond, but it's a double bond where there would be a carbon right here and there is an oxygen right here. So it's not a double bond between carbons. So it does not count as an alkene. These are all alkanes. These guys here are all alkenes. So notice this one's here has a double bond right there. That's a carbon. That's a carbon. Double bond between carbons. That is an alkene. This one has a double bond here, but that's not what makes it an alkene. It's these two guys right here that make it alkenes. That's a carbon, and that's a carbon, and that's a carbon. And same thing over here. There's a double bond right there, and then there are three double bonds in this ring structure. So that ring structure is also making it an alkene. And then finally, alkynes involve triple bonds. So there's a triple bond right here, a triple bond right there, and a triple bond right there. You'll notice that triple bonds are like very obvious. It's almost like frustrating how like beautifully sort of symmetric double bonds are, and the single bonds make these nice smooth shapes. And then there's just like this like really bloated, awkward triple bond that's just like, and I'm here too. That's like poking off the side and like very, very obvious in all these structures. So I would like to point out, I think I'm going to need to add this example for the later ones, but even if this was a triple bond to a nitrogen, again, this would still be an alkane because it wouldn't be a triple bond between carbons. All of these triple bonds right here are between two carbons, so they are alkynes. Okay, the next thing that we're going to kind of talk about here is related to this a little bit, and it's saturated versus unsaturated. Now, I assume you've heard of these terms before, and the most likely place you've heard about them is saturated versus unsaturated fats. But I'm sure you haven't heard what it means for something to be saturated or unsaturated. You might think, I'm pretty sure unsaturated fats are the bad ones. Maybe saturated fats are the bad ones. You might be trying to kind of remember that, but you probably don't actually really know what they mean. And now's the moment to explain it to you. Saturation in chemistry refers to the amount of hydrogens attached to a carbon. A molecule is considered saturated if there is only a single bond between the carbon atoms and everything else is hydrogens. If it is just chock full of all of the hydrogens that it could have, it is saturated. So alkenes and alkynes are unsaturated. As soon as you have a double bond, if that double bond wasn't there, you could cram more carbons into that compound. So it is not saturated, it is unsaturated. It is not at the maximum level of carbons or of hydrogens that could be contained in that molecule. So looking at these two, you might notice they're very similar with one very minor difference, as there's like a blatant, like, looks like someone like laying down flat and then like a broken spine. So this is all one big carbon chain. Now notice there is a double bond of an oxygen right here. And yes, I'm aware, but that is not an alkene or an alkyne because it's between a carbon and an oxygen. And the same thing is down here. So the difference here is that this has a double bond here in the middle, and in about the same position here, we don't have any double bonds. So which one is saturated? It would be the top one. I thought it was going to go to the next slide and be like, oh, it's the top one. I was wrong. So it'd be the top one. Because every carbon that is in it, that again, these don't count for that, but in this big long carbon chain, everything that could be a hydrogen is a hydrogen. This point here, if we broke that, we could add another hydrogen to this carbon, add another hydrogen to this carbon. So this is an unsaturated molecule, and this is a saturated molecule. And actually, this is could be considered a piece of saturated fat, and this could be considered a piece of unsaturated fat. This little chunk here is actually one of the building blocks of a fat molecule. So what about in real life, though? I assume you might be trying to kind of hearing. The most likely place, like I mentioned has been saturated and unsaturated fats. And off the top of your head, you might not really know the difference between them. You might assume one is bad, the other one's good. And you're kind of right. So I'm going to make this as a kind of a digital assignment that will be up. I want you to try to figure out the difference between saturated, monounsaturated, polyunsaturated, and trans fats, chemically speaking, the usual states of matter of each, and which of them is considered the most unhealthy. So I'm going to release you guys on that assignment. The next video will probably have, I don't know if it'll have the answer to it. I'll see. We'll see how that goes. Let me click quickly to, nope. Okay. I hope that you guys couldn't, we're going to pause the video and I'm going to make sure there wasn't anything important on that slide. I'm back from my unpaused video. Yeah, I guess there was some information on there, but I assume I clicked there so fast that you guys didn't really get to see it. So I'll explain that in a later video. The next video will be me going over functional groups. I'll come back and talk about this and probably release it on Sunday. The assignment of what the difference between them is, I think, is probably going to be either a digital assignment or I'll work it in with the first worksheet. Not 100% sure just yet, but that brings me to the end of this video then. This is Mr. Diamond signing off. I hope you have a great rest of your day. If you have any questions, feel free to send me an email. See you guys.